We left off with me introducing you to Yellowstone in Wyoming. This map on the lower right shows the Yellowstone National Park outline here, and then this dashed line is the state line of Wyoming. And shown in the darker brown are three different calderas formed by three Yellowstone eruptions that have happened over the past 2 million years. The first one I've highlighted in yellow here, and this was 2 million years ago, and this entire region became a caldera. After the 2 million year eruption, another one occurred at 1.3 million years. This was the smallest of the three, and the caldera was not nearly as big, and it was contained within the older caldera. Then finally, about 640,000 years ago, the third eruption occurred. The caldera rim is shown in green. Now, if you're good at math, those are occurring every 600,000 years, so maybe it's time. The eruption would be very catastrophic because it's rhyolite. Sometimes these rhyolite eruptions are called supervolcanoes because they're so enormous and explosive. They're global events that change the weather because of all the material that's put into the sky. They block sunlight, etc. So these are really major events. And as I mentioned in the last video, we've never witnessed a rhyolite eruption. Just to give you an example of the size of the most recent eruption, it was 1,000 times more powerful than the 1980 Mount St Helens eruption. Another thing that you see here are these little lighter brown areas here and here that are labeled resurgent domes. And what those are is just like it sounds, the caldera floor domes upward because magma is starting to rise in that area and push it upward. And so in this side view here of the caldera, you can see that there's a resurgent dome right here where the floor of the caldera is being pushed upward. Yellowstone is very famous for Old Faithful, the geyser that's there, and other things that are related to hot springs. The water doesn't come from the magma. The water is groundwater, but it's heated by the presence of the magma chamber. And so that's what makes the water hot. And in fact, just about all hot springs have their source as groundwater heated by a nearby magma chamber, not water coming from the magma. This is showing the ash distribution of a couple of these Yellowstone eruptions, as well as Mount St. Helens, to give you a comparison. Remember, Mount St. Helens is an andesite or stratovolcano. So here's the ash fall from Mount St. Helens in this redder color, and this is where the vent is. The three Yellowstone calderas are shown here. The 2 million year old ash distributed in this particular way and included Los Angeles region for sure. The 1.3 million year eruption is not shown here, but the ash for that one kind of circled around this way right here. Like I said, it was smaller. And then the most recent Yellowstone eruption had this particular pattern for the ash fall. Now, there's another thing that I'm showing you on this diagram, and that's called the Long Valley caldera, and that ash limit is shown here in green. We're going to talk about this when we talk about California volcanoes, but Long Valley caldera erupted less than 1 million years ago, and that's the distribution of the ash, and it is currently the location of Mammoth Mountain and other places that people like to visit. There are hot springs up in that region if you're familiar with that, and this is why. But we'll talk more about that when we talk about California. This is a nice little diagram to kind of get a feel for how much material is erupted. So this is showing prehistoric eruptions on the left. We have the largest Yellowstone one at 2 million or 2.1 million. Then the 1.3 million Yellowstone is about this volume. The 0.64 million was here. And then here's Long Valley, California at 0.76 million years ago to show you by comparison the size of the magma released. Now over here we have some 19th and 20th century eruptions, and I'll just point this one out right here. This is Mount St. Helens and the volume of that particular eruption. If you're familiar with Pinatubo, which erupted in 1991, that one is shown here. And then back in the previous video, I showed you in my very first slide, Anak Krakatoa, which was the baby Krakatoa. So the Krakatoa eruption, which was the one that was heard 3,000 miles away, is this one right here. So these here are not rhyolite. These are rhyolite. So there's a huge difference. Now, another thing about Yellowstone is that it's a hotspot. It's a continental hotspot. So far, we've talked about things like Hawaii, where the hotspot is being created on oceanic crust. But this is a continental hotspot. So here's Yellowstone today in the corner of Wyoming, and point 6 is the most recent eruption. As you go back along this swatch, these are all volcanic rocks, and they even make up a large area called the Snake River Plain. And the ages and millions of years ago of their eruption is shown here, back as far as the McDermott Field. What we believe is that the Yellowstone hotspot arrived, it poured out the massive flood basalts of the Columbia River Plateau, and then the North American continent has moved over it, just like the Pacific Plate moves over a hotspot. But in this case, we have the North American plate moving in the direction of this blue arrow, and we're assuming that the hotspot is staying still. So here's the hotspot, here's the North American plate. So we get the McDermott fields, and then the 6 million, 4 million, 2 million year old volcanic events, and then the current Yellowstone is right here under the hotspot. So the North American plate keeps moving, and that means that in the future, the eruptions will migrate to the northeast over here. This is a good example of magma assimilation and mixing, because the magma coming up is mafic, but because it's coming up through continental crust, it's melting a lot of that felsic material into it, and it's becoming more and more felsic over time, and that's why it's a rhyolite volcano and not a basalt volcano. Okay, we're finally on our last volcano, number 6. These are stratovolcanoes, or sometimes called composite, because they usually consist of alternating flows of lava and pyroclastic material. Now, in the next video, you're going to learn about what kinds of things come out of volcanoes, and pyroclastic material is one of those things, and it's shown here in this cartoon on the right. Pyro means fire, clastic means bits and pieces, and so this is a huge explosion of ash, little rock fragments, very, very hot gas. And when these things erupt, they rise, and then eventually they sink back down, they collapse, and then they go flowing off and covering the land at speeds of hundreds of miles per hour. These are the typical volcano shape, the cone shape with steep slopes. Many of them, because they're so tall, wind up being pretty high in elevation, and thus they have snow on them either part of the year or all of the year. And so this is a very classic look of a stratovolcano. They are extremely dangerous. Even though they're andesite, they're significantly dangerous. You don't want to be in the way of these. They're also very common at subduction zones. So this would be the result of flux melting. This is just showing what the inside might look like if you could kind of take an image inside. We've got a magma chamber, and then it feeds up in the dikes and the sills as it moves up through the pre-existing volcano. We have a crater on top with the vent, and then we might have what's called flank vents on the side of the volcano, etc. A very famous stratovolcano eruption was Mount Pelée in 1902 in the town of St Pierre, Martinique. And this generated a pyroclastic flow. And this is Martinique before the eruption, and the volcano is just kind of here off the picture. So this happened suddenly. There was no warning from Mount Pelée that she was going to erupt. There's an image of that someone was able to get of the pyroclastic flow, and this is what was left behind. Pretty much nothing. And this is in the Lesser Antilles Arc. Martinique is right there. So that's a subduction-related volcano. Now, the story goes that 2 people survived out of the entire population. One was a girl on a raft who was found 3 miles offshore, and the other was a prisoner who was in a dungeon, and somehow that dungeon kept him safe from the pyroclastic flow. Do you think people repopulated this area? Of course they did. Here's St. Pierre today, or a couple of decades ago. There's the volcano, Mount Pelée. And here you can see the fishing port has all been redone, and there it is today. So sometimes memory fades and people forget how powerful volcanoes can be. We also can't finish our discussion without mentioning Mount St. Helens. All of the Cascade volcanoes, including the 3 in California, are subduction related and active, and they're all andesite. Now in 1980, Mount St. Helens looked like this. It was an area where people went hiking and camping, and this is Spirit Lake in the foreground. And this is located, here's Seattle, here's Mount Rainier, and here's Mount St. Helens, and there's the Oregon-Washington border. And so here's a little cartoon of what that might look like. And then the eruption occurred, and we were left with this. So this is what's left of Spirit Lake. All of this material down here are the trunks of the trees. The needles of the trees were destroyed. That's what's left of the logs. And what was surprising about this eruption was that it sort of went sideways instead of up. And you can kind of see that, especially in this cartoon here, where it looks like most of the volcano is still there except this one side. So this is a little sequence of events of what happened. First, the magma was rising over a period of weeks. There were bulges on the volcano. Volcanologists knew it was going to erupt. They warned people. And then this avalanche occurred, and it opened up that vent to the surface. And so what happened is the material blasted about 20 miles to the north. It even killed a geologist who was filming it because he thought he was completely safe way out there. So that was an intense eruption because it wasn't expected to go in that direction. And it also was the first eruption on American soil, so American geologists got to study it. You might want to pause and take a screenshot of this. This is a great summary of all 6 types of volcanoes. Coming up next, you're going to watch a City College of San Francisco video that's going to talk about eruptive products that come from volcanoes.